Hi, linear algebra students. This is the end of section exercise of echelon forms, section 1.2. So you have a system with two parameters now, okay? So one of the parameter is this k that is found twice in the coefficients. And you have this parameter h that's found once in the constant column, okay? And what we want to do is to find all the combinations of h and k for the system to have infinitely many solutions, no solution, or a unique solution. Okay, first I'll minimize the color code in this problem because, well, actually my color code is going to be mainly on the k's and h, but even then I'm going to color code them once and that's it. But I'm also going to solve the entire problem in blue because I will have to erase a couple of times and I will leave this black on the board. Okay? So the first thing to do is to copy the matrix. Okay, now one thing that it's important to realize here is that the variables are x, y, and z. Okay, so let's actually write that down. Variables. Okay, why do I say this? It's just because don't think that h and k are variables. H and k are parameters of the system. Okay, so depending on the values that h and k each take, the system might be consistent or not, might have a unique solution or not, and so on. But they are not variables of the system. The variables are just x, y, z. So this means that h and k will enter our matrix, okay? But x, y, and z, since they are the variables, they don't enter the matrix. So here, for example, the first column is 1, -1, 0. The second column will be 0. And here, as you can see, the k enters the matrix at this point. And then 2. And the last column will be 2, 6, and 4k. Now the column of constant will be 1, 3h, and 2. All right, now what we want to do is to row reduce this. Okay? So, okay, we are happy with that one. So we're going to take it as a pivot, which means we're going to make this -1 a 0. We already have a 0 here, so we don't need to change the third row for now. So we're going to do row 2 plus row 1 becomes row 2. So in other words, we have 1, 0, 2. And then, oh, I will put the 1 immediately. Then I'm going to change this row. I'm going to have 0, then k, 8. And finally, oh, I put this too fast. 3h plus 1. Okay? Now here, this row doesn't change. Oh, actually, look. Notice that this row has multiples of 2. So we're going to take advantage of that. We're going to scale it down. So row 3 times 1/2 becomes the new row 3. Okay? So in other words, we're going to have 0, 1, 2k, and 1. All right. Now let's have a look at a couple of row operations that are not good. Okay? So the basic mistake is to want this to be a pivot. Okay? In other words, this k over here, you would like to change the k in order to make this a pivot. This is a mistake. And it will lead you to do two kinds of row operation that are both not allowed. First one would be, for example, to do row 2 times 1 over k becomes the new row 2. This is wrong, okay? One other mistake that you might be tempted to do is to do row tree times k becomes the new row tree. In order to make this a multiple of k, you would do that operation. And this is also not good. The reason why these are not good is because k could actually be 0. And multiplying a row by 0 is not an elementary row operation. It will change your solution set. Okay, let's write that down actually. So these are not allowed since they are not ERO when k is equal to 0. Okay? One thing that you could do is to solve the case k equals 0, get it out of the way, and then do these row operations, but specifically in the case for which k is not equal to 0. But there's another way around it, and it's actually the smartest thing to do, is to choose a different pivot. So in other words, you will choose a pivot that doesn't contain k. You will make this one a pivot. If this one has to be a pivot, it means that you need a row interchange. So the row operation you need to do is actually row 3, row interchange with row 2. And the resulting matrix, obviously, so 1, 0, 2, and then 1, and 0, 1, 2k, 1, and finally you have 0, k, 8, and 3h plus 1. Okay. Now I'm gonna cheat a little bit. The last row operation, I'm gonna make the matrix over here. And the reason is because after that, I will erase everything except for the last matrix in order to answer the 3 questions that are over here. Okay, so all right, notice that this one is a pivot, so we want to cancel the k, and the appropriate row operation, so which is gonna be done over here, is row, yeah, that's it, row 3 minus k row 2 becomes the new row 3. Now, one thing you might ask is, why is this allowed, but these two are not allowed? And the reason is, look at what's happening if k is 0. If k is 0, row 3 minus 0 row 2, so in other words, just the row 3, becomes the new row 3, which means that you're not changing anything, which is certainly allowed. It's not an elementary row operation, but it will not change the solution set because you're just not doing anything. Okay, but doing this in general, even when k is not equal to 0, will lead to the row echelon form. 1, 0, 2, 1, 0, 1, 2k. And here actually I will pull this a little bit. I will copy the coefficients first. And then here, okay, 8 minus k times 2k. So that's going to be 8 minus 2k squared. And then hopefully I have space. 1, 1. And what's going to happen here? 3h plus 1 minus k times 1. So we have here 3h plus 1 minus k. Okay, so that was closed. Hopefully you see the last matrix well. So now I'm erasing everything except, I'm even gonna, do I erase this? No, I'm not gonna erase this. I'm just gonna erase the row reduction. So now we answer the questions one by one. First, in order to have infinitely many solutions, you need to, okay, so first of all, let's circle the pivots. Okay, so we have like this one, okay? And this might be a pivot or not, depending on the value of k, okay? In order to have infinitely many solutions, you don't want this to be a pivot. In other words, because if it was a pivot, you'll have a pivot in every column. In other words, a unique solution. Okay, so and in order not to be a pivot, it has to be zero. Okay, if it's not zero, it's going to be a pivot no matter what. It can be scaled down to a 1. Okay, so we want so 8 minus 2k squared equal to 0 for in order not to have a pivot in third column. But we if this is 0, we have a row of 0, so we might actually make the system inconsistent by accident, because that's what's happening when we have all 3 zeros here and this is non-zero. So we need to ensure that this is also 0 in order to have a row of 0 equals 0, which means that consistency is preserved. Okay, so we also want 3h plus 1 minus k equals 0 for consistency. And now you solve this in a regular algebraic way. So for example, let's start with this. Okay, so 8 minus 2k squared equal to 0. So it's very easy to solve. So for example, if you move this on the other side and divide both sides by 2, you're getting k squared is equal to 4, which means k is equal to plus or minus 2. Be careful of the plus and minus, a recurrent mistake, right? Now, if k is equal to negative 2, let's start with that, okay? So actually here I will color code, because what we're going to do is we're going to replace the value of k. If k is equal to negative 2, it means that 3h plus 1 minus negative 2 is equal to 0. Okay? Now you solve that for h, and what you're going to obtain is h is equal to, or actually let's just solve it. Let's not go too fast, in other words. 3h plus 3 is equal to 0, which means h is equal to negative 1. And you do the exact same process if k is equal to 2. Okay, so you replace. You want 3h plus 1 minus 2 to be equal 0. So in other words, 3h minus 1 equals 0, which means h is equal to 1/3. So the final answer here is h is, well, actually, k is equal to negative 2. H is equal to negative 1. Or k is equal to 2 and h is equal to 1/3. So this is the answer to letter A. Okay. Let's now follow up with letter B. Okay. Once we have done letter A, letter B is quite easy, because what we want is almost the same thing. Okay? So what we want is a pivot in the column of constant in order to have no solution. Okay? So we want a pivot in the column of constants. And what we mean by this is we want 8 minus 2k squared equals 0, because if we have a pivot here, it's impossible to have a pivot in the column of constant. So we want this to be 0. In other words, we don't want a pivot here. That leaves the space for this to be a pivot, but it also means that we want this to not be 0. Otherwise, it will also not be a pivot. So, and 3h plus 1 minus k is not equal to 0. And from there, it's exactly the same process. So first, this equation forces k to be equal to plus or minus 2. And then you go again. If k is equal to negative 2, okay, so actually, yeah, again, I will color code this. If k is equal to negative 2, so we want 3h plus 1 minus negative 2, but this time to not be equal 0, okay? And here you conclude that h cannot be equal to negative 1. If k is equal to 2, you want 3h plus 1 minus 2 to not be equal 0. So in other words, h will not be equal 1/3. So as a result, the answer is k equals negative 2. Or I'll just put a comma. H is not equal to negative 1. Or k is equal to 2. And h is not equal to 1/3. So that is the answer for the no solution part. Moving right along, I erase again the blue part, and we're doing C for unique solution. That's the easiest one. Okay. In order to have a unique solution, remember that what you need is a pivot in every column of the coefficient matrix. So in other words, we want a pivot in the third column. So we want a pivot also in the third column. So this means we want 8 minus 2k squared to not be equal 0. Okay, now we solved this equation a good couple of times. And notice that if this is not equal to 0, we don't care about if this is 0 or not, because if we have a pivot in every row, then, well, that's it. If we have a pivot in every variable, so it means like in, well, that's it. If we have a pivot in every row, we cannot have inconsistency, okay? So I will put here regardless of 3h plus 1 minus k. So we don't care about if this is 0 or not. And then we solve this equation a lot. So let's just write the solution. We want k to not be equal to 2 or negative 2. Okay, so in other words, the answer is k is not equal to 2 and k is not equal to negative 2. And this is regardless of h, because h is actually the only thing that that depends on h is the constant. So if we have a pivot in every column, in every row, actually, if we have a pivot in every row, then the system will be automatically consistent and we're good. So this is the answer to letter C. I hope this was helpful. So see you in the next topic.